Okay, so it's me, Ariel, and we had to present a topic that we learned in chemistry for Miss Rogers' class, and I'm doing the Chatelier principle, and it's all about shifts from equilibrium. So let's get into it. The Chatelier principle. The Chatelier principle is applied when there is a change in conditions that displaces it from equilibrium, and the reaction shifts in a direction that offsets the change in conditions. So that means that originally a reaction is at equilibrium, but then something happens and it causes it not to be at equilibrium. And the reaction wants to get back to equilibrium, so it does whatever it can, thus shifting to return back to equilibrium. So the three factors that can affect the reaction at equilibrium are a change in the reactant/product's concentration, the reaction's volume or pressure being changed, or a change of temperature. Oh, and I have a joke on the majority of the slides, so this joke is on the Chatelier principle, and it says, if stress is applied to a system in dynamic equilibrium, the system will adjust to relieve the stress. So there's a whole bunch of homework, and a person's like overwhelmed with homework, and then they're bringing the homework because, they're trying to relieve the stress and return to equilibrium, which, that's funny. Okay, yeah, sorry. Okay, so first factor, change in concentration. Increasing the concentration or decreasing the concentration of a product/reactant will cause the reaction to shift in the direction that will return the reaction to equilibrium. Okay, it seems like I'm talking really fast, and I'm sorry about that. And it's pretty self-explanatory. So if the concentration of a product or reactant increases or decreases, it will cause a change from equilibrium, and thus the reaction will have to be shifted in some way, shape, or form. So in my example, A2 plus B2 was 2AB. I'm going to give some kind of like hypotheticals of what they could ask about the shift. So if you add A2 to the reaction, then it would try to shift right and compensate for the A2 that was being added. If you add AB, then the reaction would shift left to try and compensate for the AB that is being added. If you take away B2, then the reaction would shift left and try to compensate for what is lost. It's all kind of pretty self-explanatory. So, there's a joke. The best thing about learning about equilibrium is that nothing changes, which, everything changes. A change in volume or pressure. So, my example is 2H2S plus 3O2 yields 2H2O plus 2SO2. So, the amount of moles on each side of the reaction also plays into the role of how the reaction will shift. So if the pressure is increased, then the reaction would shift to the right because there are more moles in the reactants, there are 5, compared to the products, which have 4. So by shifting the reaction right, then there would be a decrease in pressure of the reaction since there are less moles on the right. So the shift would also occur if the volume is being decreased. If the pressure is decreased, then the reaction would shift left because there are more moles on the left. Shifting the reaction left means increasing the number of moles in the reactant, which would then increase the pressure and return to equilibrium. So the shift would also occur if the volume is being increased. So, the shift would also occur with volume. So they might not tell you pressure, but pressure and volume have an indirect relationship. So if volume goes up, then pressure goes down, and vice versa. So another thought to keep in mind. Sorry, there's no joke on this slide. I'm really sorry. There's like no room. But it's gone. Wow. Okay, so change in temperature. My example is adding heat to the left side of the reaction. So heat is added to N2O4, which yields 2NO2. So this reaction is endothermic because heat is positive and it's on the left. So it causes the reaction to shift to the right when it's being cooled. So when the reaction is being cooled, then it's a shift to the left since there is a loss of heat. So, like, they're trying to compensate for the heat being gone. And then when the reaction is being heated up, then it's a shift to the right since there's an increase in heat. So they're trying to compensate for the fact that there's more heat being added. But on the other hand, there's exothermic, which means the heat is going to be on the right side and heat's going to be negative. So it's the same reaction, but heat is on the right instead of the left this time. So it's a negative. And when the reaction is cooled, then there would be a shift to the right because, the heat is being lost. So they're trying to make up for that. And when the reaction is heated, then it would be a shift to the left because heat is being added. So that's the last joke. When you know chemistry jokes, but they all boron, get it? It's like a play on words. It's pretty funny. Yeah. I'm just not going to explain it. But I just want you guys to see the last slide, which is a works cited, because it's always necessary to give credit to those whose information you use. And I use the pictures and I use the textbook to get information from for this PowerPoint. And I just want to say that Miss Rogers is probably one of the best teachers I've ever had, and she's brought so much joy into my junior year, and I just want to thank her very much for all of this, and it means the world to me. So thank you for being such an inspiration, Miss Rogers. I'll never forget you. Have fun in AP Chem.